Hey guys, this is we're looking at the static friction section of the homework and classwork, and we determined, I believe it was number 55, and now we're going to look at one that actually accelerates. So I'm going to go down to number 62, okay, where we have a situation where there's a stationary 250 kilogram object. So the mass of the object's 250 kilograms, is located on a table near the surface of the Earth. The coefficient of static friction, so that's mu sub s, is 0.3. And the coefficient of kinetic friction is 0.15. Okay, so static friction is the friction at when it's still. So think still, static. Now, once you break free, it now switches over to something called kinetic friction. Let's see what else it has. In number 62, it says a horizontal force. So we'll say force applied is 1,500 newtons. Okay, it says A, draw a free body diagram with the forces to scale. Okay, well, here's our object. Okay, we've already said that there's a force 1,500. This is the force applied. Okay, we know that it has a weight to it. Okay, we know weight is mass times the gravity. We know the normal force is equivalent to the weight and in the opposite direction. And we also know that there's going to be some frictional force, a static one, and also a kinetic one once it's moving. So let's first find out what the weight of this object is so we can figure out the normal force. Weight is mass times acceleration. The acceleration is going to be gravity because it's pulling down. Okay, so if I figure that out, I can just plug that in the calculator. Okay, I had mistakenly put the 1,500 here. That's the applied force. Our mass is 250 kilograms times 9.8. So the weight is 2,450 newtons down. So the normal force, because this is not accelerating through the table, has to be the opposite of that. Okay. So now we've got the normal force is 2,450 newtons. The force applied is 1,500. And we want to figure out what the static friction is. What does it take to get this object to like break free of its friction? Okay, let's see what that is. So the force of friction, static, is equal to the mu static times the normal force. Remember, physics is fun. Okay, so the force of friction, static, is equal to, let's figure it out. The static mu value is 0.3. So F force of friction static is 0.3 times 2450 newtons. So let's see what kind of friction we have. 0.3 times 2450. So look what we have here. We have a static friction, 735 newtons. That means that's what it takes to break this thing free of its static. Now, here's the confusing part. Well, once I get it moving, the kinetic friction reduces. That means that we actually get less friction as this object's moving because it's already broken the tips of the surfaces which it rests. So yes, we can get it moving because we're applying 1500 to it. No problem. We can beat that 735. But now I got to come up with how much actual kinetic friction do I have? Force of friction, kinetic, will be mu kinetic times the normal force. So let's figure out what that is. Force of friction kinetic is 0.15. That's my kinetic coefficient times 2450. So let's see what we got there. 0.15. So my force of friction kinetic while it's moving is 368 newtons. So force of friction kinetic is 368. So this 735 is no longer useful. Okay, we know that that's what it takes to break it. But in reality, as this is accelerating this way, its kinetic friction is going to be 368 newtons that way. So we're not done yet because we've got to figure out what the so we determine the force of friction, both of them. Force of friction static is 735. Force of friction kinetic is 368 newtons. Now we've got to figure out what the acceleration of this object is. Okay, so we know that according to Newton's second law, force is mass times acceleration. We're solving for acceleration, so we're going to rearrange the formula. Okay, acceleration is net force over mass. So the net force, well, the up and down cancel. Those are 0. I've got a 1500 pulling to the right. I got a 368 pulling to the left. 1500 minus 368. We'll put a unit on there. Divided by the mass. The mass was 250 kg. So if I figure out what the acceleration is by taking the net force, that's the addition of all the forces in this whole deal. These are 0. Don't worry about the up and down. This is 1500 minus 368. So my net force, okay, I'll bring this over here a bit. So acceleration is the net force over mass, which is equivalent to 1132 newtons. We subtracted that to get the 1132, divided by 250 kgs. So let's figure out what that is. Okay. Acceleration of this object is 4.5 meters per second squared. Okay, and that was part C of number 62. So as you can see, these problems are in depth, but you've got to just take a methodical approach to it. First, figure out if you can break the friction. Yes, you can. And then figure out if you can get the acceleration from the net force. Okay, because that's why we use net force here. Okay, hopefully that helps.